Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking at the UNIX Philosophy. This is kind of an answer to Derek over at DistroTube's video on his thoughts about the UNIX Philosophy, and so I'm going to provide you with mine. Stay tuned right after those. So the UNIX philosophy, what is it? I mean, you can go out to Wikipedia and you can look, and you'll find it's very disjointed. Has a lot of comments by different people that have over time put their own fingerprint on the UNIX philosophy. I don't know if they're trying to claim it as their own or they're trying to put their own spin on it, but I mean, it's very misleading over there. Let's talk about what it was from the Bell Labs perspective, because they're the ones that invented it. So I guess the first place to start is with Fred Brooks, The Mythical Man Month. This book was released in 1975 in its first edition, and there was several releases of it afterwards where he made additional updates to it. Fred Brooks was the project lead for IBM, and he developed the OS 360 operating system. It was late. It went way over budget, and because they were late, they made the mistake of adding programmers to an already late project, and instead of bringing it back into being on time, it made it later. And so he was kind of brought into crossfire by the CEO of IBM at the time, and had to explain to that CEO why his project was always late and over budget. So the thing that everybody quotes about the Mythical Man Month is adding programmers to an already late project makes it later. So that's the quote you will always hear. But there was a lot more in that book than just that. One of the things that he said was second system effects, or second system syndrome. That's the tendency of a small, elegant, and successful system to be succeeded by an over-engineered, bloated system due to inflated expectations and overconfidence. So, in other words, that what you got right in the beginning, you end up with a piece of junk later, because you get all these people that come in thinking, oh, I could do better than that, and they begin trashing what you had designed so elegantly. And that the Bell Labs people knew that would be a problem. Ken Thompson was in charge of the developers inside of Bell Labs, and Dennis Ritchie was responsible for the compilers and working on getting some of the other things working on Unix. So the Unix philosophy it's an approach to create minimalist modular software and incorporate that into the software development design process. Dennis Ritchie also contributed to that. It became a cultural influence, not only inside of the Unix group, but it expanded beyond their walls and spilled over into other elements of Bell Labs as well. Where did it come from? Was it just something on a blackboard that people said, oh, this would be a good idea to maybe follow, and maybe we'll do that, maybe we won't? No. This was based on experience of leading developers of the Unix operating system development or design. So it brought concepts of modularity and reusability because they needed that, and they wanted that to be a part of the project so that they could shorten the time to develop new features down the road. So they were thinking way ahead. They weren't just grinding out some code and doing the least amount of work possible, and they didn't really care about it. They wanted a well-oiled, well-fitting together machine. So it was, and the Unix philosophy to Bell Labs was just as important as the operating system was to itself. So yeah, it was a very important piece of that puzzle. But what was it? What the heck was it? So we already talked a little bit about it, but let's talk about it a little bit deeper. So it was an emphasis that was placed on building simple, short, clear modular and extensible code that could be maintained and repurposed by developers other than the original creator of the code. So it would be, I should be able to hand over this code to somebody else. They should be able to repurpose it or reuse it for whatever they need in order to fit the needs of the users that were requesting these changes. So the UNIX philosophy, it really favors composability as opposed to monolithic design. What's monolithic design? OS 360 was a monolithic design. It's where you have all of the code in one huge one huge baseline that then is compiled and it creates this monster. Composability is really trying to take the system design and deal with the interrelationships between components. So it's sort of like I'm going to build a set of applications out of the components like Legos. So I take a bunch of Legos and I build up a design, and now I have the Battlestar Galactica or whatever it is that I'm trying to build out of it. But I start with little pieces and then I build it up around there and assemble them. So, but the advantage to these components being built this way is that I can pick them apart. I can pull that component off and I can make a copy of it and I can reuse it in something brand new, a brand new system that is closer to trying to meet the needs of my users and at a fraction of the cost it would take to develop something brand new. So the traits, what would you expect to see in a composable system? Or a component. So it would be modular, it would be self-contained. That means that I should be able to lift that part out and throw it away. One of the projects I worked on, the Air Force was so fed up with the contractors building in this self-protection mechanism in their code so that they could never be gotten rid of. And so what they wanted is they were trying to convey to us that you will conform to basically this composability design standard that says your part should be able to be lifted out and replaced. And that's what they want. They didn't want it dependent on other components. So if you had that dependency, no, you weren't going to survive. And that's what Unix was trying to do as well. The other part of it is it needs to be stateless. So each request is an independent transaction. There should not be any history or anything that's related to a previous request that's left over. If you looked at any of the early designs that Tim Berners-Lee did for the web server that he initially wrote and published, all of that was stateless. In fact, I remember, there was times when people were forcing state to be in there because they wanted to conduct transactions with the application server, and Tim was like, you're going to have to do that in a standalone. I don't want this polluting my software base. Well, he eventually lost that argument, unfortunately. So what? Why is that a big deal? Who cares about composability? Well, the thing is that about composability, it's widely accepted among a lot of us anyway, that it's more trustworthy than other non-composable systems. So it's because it's easier to evaluate the individual parts that make up the system. I can look at all the pieces that go into it, and I can see, that's good, this is bad, this probably needs to be rewritten or whatever. Dennis McElroy was the head of the Unix development lab at Bell Labs. So he was the boss for Thompson and Ritchie. So in 1978, he was writing a front piece. Dennis Ritchie had written a paper called Unix Time Sharing System back, I think, in 1974, and he was republishing, updating it a little bit, and republishing it for the ACM. And they needed a preface to that paper, and so Dennis McElroy wrote the preface in an article that was going to accompany what Dennis Ritchie had written. So let me just, in there, he describes what the Unix philosophy was. So rather than me tell you, let me have him tell you. Just let me bring it up here. So there's the paper. At least part of it was published in the Bell System Technical Journal in August 1978. And this was written by, this is the foreword that goes in there. And I'm just going to kind of slip down here a little bit. And right here in the style, he talks about the maximums that have gained concurrency among the builders and users of the system. So this is what actually his vision was, the way he articulated what the UNIX philosophy was. So, and this is the thing that a lot of people quote, and they get it wrong. Most people say, well, make each program do one thing well, and that's where they stop. But that's not what he meant. There's more to it than that. He said to do a new job, build it afresh rather than complicate old programs by adding new features. In other words, don't just go in and just, jam this new code in to an already existing program. Think about what you're doing and create something new out of it. So the other one is that because you don't know how this is going to be hooked together with other programs, the axiom here was expect the output of every program to become the input of another. And he wasn't talking about, oh, well, this only applies to it if you're using pipes. No, it wasn't talking about that at all. What he was talking about is you don't know what program it's going to be, so don't clutter the output with any kind of extraneous information. Don't clutter it up, and don't make it a columnar or binary formats or some proprietary crap that you would have to use that only you would understand and only you could use. And don't insist on it being interactive input. That's what he was saying. The other one, and that is the basis for how to get data to flow evenly throughout the system, by the way. You want to design and build software, even operating systems, to be tried early, ideally within weeks. So this is kind of the prototype type of phase, Kanban, whatever you want to call it. But I need to be able to get something out early so that people can start to take a look at it and make comments. All too often in the old days, we would spin up these large projects that would take years to develop the software. And then we'd go to the user. Well, by the time we got it to them, they'd go, I don't need that anymore. I've got a different way of doing things. And that's not even what I wanted in the first place. So you want to have something that you can show them early. Make sure that you have something within a few weeks. And then don't be hesitant about, don't take a pride of ownership in it. If it's crap, admit it, own up to it, and then throw it away and rebuild it, make it better. So that was kind of their rules. I know a number of times it was kind of funny when I remember one of the guys over in Indianapolis from Bell Labs over there. He said, well, here's the thing. If you want to write a utility here, the best way to do it is just go start working on one that's already there. I guarantee it, you'll own it inside of a week, because generally once somebody has done something, they don't want to go back and work on it again. I thought that was pretty funny. So you want to use tools and preferences to unskilled help or to lighten a programming task, even if you have to detour to build the tools. So in other words, if you need to create tools that'll help you automate something or help you be able to test something, great, use them, and even and expect to throw some of them out after you finish using them. Don't marry. I mean, one of the things I remember that the Bell Labs guys would always say is, don't get married to the code, because chances are it's going to have a real short lifetime anyway, because somebody somewhere along the way is going to come up with something better than what you had thought of. And yeah, that happened all the time. But that's good. I mean, that's how innovation brings itself into light, is that you have some ideas that expose and generate other good ideas, and those new ideas get built back into the system. So that's what you want, I think. I mean, my opinion is that's exactly what I would want. So, I'll probably need to put a link in my show notes for you. I don't want to spend a lot of time on this. This is a copyrighted work. So, but, you can read through this. There was a number of axioms that are basically legend inside of Bell Labs that became part of it. And just to cover one of them is that compilers at the time didn't produce any listings. Well, a lot of people said, wait a minute, where's the listing for the compile? How do I know what it did? And Bell Labs' answer was, well, we have other utilities for that can do, a better job of printing it out for you and let you know what took place. So we don't want to build that into the compiler. We've already got something that will do that report format for you. So, and that allowed them also to take that same output from the compiler and pipe it into a typesetting program so that the source code could be published as part of an article or a book or what have you. If you look at the C book that was written by the Bell Labs folks, if you read that, that's all typeset. That's all typeset that's in there. And all that code, that's how it was generated, was through that. So the other thing is that the Unix and the C language evolved by deliberate steps. So they had early working models, they refined it, it's kind of a stepwise refined it, and it got recoded several times by the same people who designed it to begin with. So there wasn't this, you don't tell me what to do, I wrote this. And it wasn't that kind of thing. It was more of, okay, we're learning together, we're trying to make this better. And if I can use something, a tool that somebody else wrote to help me do my job, great, we'll do that. And that's basically the way it works. So finally, the use of tools instead of labor is illustrated by typesetting. So, a lot of people think that Unix in its early days was really a developer's operating system. No, wrong. There's several videos out on YouTube that were published by Bell Labs that talk about the early days of Unix and where it went into functioning. So if you go and watch any of those, you'll find out that the first people to use Unix were the people that needed to publish articles for journals, because that's the name of the game, get published, right? I mean, it's no different than any other academic setting. So, yeah, it was the typesetters that won out, and the NROF and TROF that were developed for Unix, those were the mainstays of Bell Labs. That's what they used them. The other thing was kind of interesting is that Fred Brooks, in a later version of his book, he kind of commented on what Bell Labs was doing with the UNIX philosophy in the small is beautiful category of Schumacher. So he said, the small is unreal. That small is totally unreal. The working of a handful of people doesn't extrapolate into the world of big jobs. In other words, big jobs, take big programs. And that kind of speaks to the IBM philosophy. And I saw that. I worked for them. I saw that. If you had two applications that did exactly the same thing and you needed funding, now let's say one of them was 1,000 lines of source code, and the other one was 10,000 lines of source code. Which one do you think would be funded? You think it would be the more elegant one? No. No. It's the 10,000 one, because people equate power or functionality with size. And IBM is guilty of that as heck. So yeah, and even to this day, they still function that way, and it just baffles me that, here we go again. It's the small and elegant is not as powerful as large and clunky, right? So anyway, so Bell Labs said, oh, well, we kind of agree with what you're saying, Fred, in part, but for us, for the present volume demonstrations with unusual force, another important factor. So that is, intelligently applying computing technology can compress jobs that are used to be big in a manageable size. So now, let me put that in English. So what they're really saying here is our data says the opposite, that if I take intelligently designed computer technologies like operating systems, utilities, compilers, what have you, I can take that job and I can shrink it even and make it down and get it down to a manageable size. And they back it up. They said the first system had only about 5 man-years work in it. Now, the first system they're talking about here is Unix. They started working on it in 1969. It went online inside of Bell Labs on January I think it was the 2nd of 1970. So it included the operating system. It had an assembler. It had a Fortran compiler. It had a whole raft of utilities. And it also had the documentation. So they were ready to go. And it began being used for Bell system projects. And of course, yeah, it was the typesetters that started using it. And actually, the time sharing was the biggest piece of it that made it popular inside of Bell Labs. But so the Unix team regularly evaluated the quality of the code that was being added to the kernel, the libraries, the compilers, the utilities. And if they felt that it was substandard, it got jettisoned. It was gone. They had it wasn't a thing of, I don't mean to hurt your feelings, but your code's crap. I'm just going to throw it out, and we're going to rewrite it, give it to somebody else, or we'll let you try it again. But this time, do it with these guidelines in place, so that you do this the right way, so that we can take that code, lift it out, and use it for something else. So, yeah, the Unix team at Bell Labs regularly gave training to new developers and also new employees. So how do I know? I worked for AT&T Data Systems Group in the late 80s. I was one of them they trained. So I went through this. I know what they were trying to do. I know what they were trying to teach us. Well, at least I came away with it. I hope I did. So finally, to sum up what Fred Brooks said when he wrote the 1980s edition of the Mythical Man Month, he said, about the book. He said, some people have called the book, being the Mythical Man Month, the Bible of software engineering. And he said, I would agree with that in one respect. That is, everybody quotes it. That is, the only part they remember is adding programmers to an already late project makes it later. So, but some people have actually read the book, and it's very short. I mean, you could probably read it in an afternoon, but very few people go by it, which I thought was kind of funny. Now, one of the things that that people always point to is that, as far as does Linux have any kind of similar type of, I don't know, philosophy or thought or how they do their development? As far as Linux goes, it's never too late. They don't, by the way. But I wonder if they really have the will to dump the cruft and rewrite it. So that, I mean, like the Unix people did when they went through the review process. It's probably too late now, because, you know, once it snowballs, you've got this, instead of working on code that's, this size, you've got code that's like this size that you have to manage. Linux has grown into almost 60 million lines of code. So, yeah, it's huge. If you don't think that's not bloat, I don't know what is. So one of the comments that Derek from DistroTube said, he also did something on the UNIX Philosophy. Unfortunately, Derek used the Wikipedia and didn't really dive into where that actually came from. And a lot of times you'll find, and particularly with that wiki article, everybody puts their fingerprint on it. I think they all kind of want to own it. They get it wrong. It's not Derek's fault. It's the people that are trying to understand something when they had not gone through the class themselves. So they don't understand what it actually is. But Derek makes this comment that says, we don't need to be concerned about the UNIX philosophy because free means freedom. And we should be free to write the code in whatever way we wish. Well, I don't totally disagree with that. However, I will say this. Free and open source software has absolutely nothing to do with writing concise, well-designed, and well-written code that can be repurposed by other people other than the creators. So, I mean, that was the core goal of the UNIX philosophy. People always say, well, it was to write something well, do one thing and do one thing well. That was an axiom that Dr. McElroy tacked onto it, but that was not the original philosophy. To me, writing concise, well-designed, and well-written code should be the goal of any software development project, because if you can't reuse your code, you've lost your money in developing it. You're not gaining anything from that code being there. So the UNIX philosophy isn't in conflict with the free and open source software movement. No, it's in conflict with bloated, poorly designed, and badly written software. If that's what you think free and open source means, well, it's sad. That's really sad, because that's not what we want. We don't want bloated, poorly designed, and badly written software. Sorry. I don't think even the developers that are writing this code have that goal in mind. At least I would hope not. So the other thing is that philosophy developed into the So that kind of what Dennis Ritchie described as the core features of the operating system that at the time no other operating system could offer. Now, since then, a lot of operating systems have copied what Unix is doing, it had done, including Linux, by the way. So Unix offers a number of features that are seldom found in other systems. Now, this was his quote at the time. So that would be a hierarchical file system that incorporates mountable volumes at any point in the file system. So I can take any directory. I can mount a file system on that directory, any of them, even dev. I don't know why you would want to do that, but yeah, you could. I wouldn't advise doing proc, though. That might be a catastrophic crash. But the other thing is that you have compatible files, devices, and interprocess I/O. Because of the simplicity in the data exchange in Unix, it was able to, an application didn't care if it was reading a file or a device, or it was reading data from a device, or whether it was coming from memory from another application. So it didn't care. The other thing is it had the ability to initiate asynchronous processes, meaning that I didn't care what order they get done in. I could just fire them off and forget, let them run, and when they finish, they finish. The other one was system command languages, or any of the applications that are out there. I could code the permissions on them on a per user basis. So some could be allowed to execute it, some couldn't. Now, Derek also made comment about POSIX that he didn't think that was important anymore. Well, maybe it's not important to Derek, but POSIX compliance is important to anyone that's exchanging data with another system. If it's not POSIX compliant, there's no guarantee that you can exchange data. And unfortunately, we had to draw from that to build POSIX compliance in order to get the systems of the time in compliant. Most of the problems was with IBM, and later it became Microsoft. So yeah, so without POSIX compliance, there's no way to assure that the data can be exchanged. So the other thing is that there's over 100 subsystems now. At the time, that it grew to quite a few more than that. But at the time, there was 100 subsystems that included a dozen languages. Now, I think he's referring to programming languages here, but it could also, Unix did have some early, some early methods for localization. So yeah. So what about the footprint? How has that changed between Unix and Linux? So the 1974 version of Unix took about 42 kilobytes of memory. It grew a little bit, and then when it got to System 4, it grew a lot. But it didn't grow a whole lot. I mean, it got a little bit bigger. I don't remember the exact what it was when I was there, but I got in at the end of System 3, and then System 5 came along. Yeah, System 4 never happened. So in 1974, it took about 42 kilobytes of memory. Now look at Linux. Linux, just the server kernel by itself, the server install minimal, will take about 8 meg of RAM, and that's just for the kernel, and 16 megabytes is what they recommend. But if you start launching the core services, you've got probably another about 59 megabytes or so, larger than Unix. So general Linux OS, if you put a GUI on it, now you're really going to shoot up. I mean, the smallest, Mate and LXDE, those take between 250 and 300 megabytes of RAM. XFCE and KDE are probably looking at somewhere around 400 to 500 meg total of RAM. And then GNOME, 1.2 is probably a little harsh. I mean, with 4.40, with version 42, you're probably looking 800, maybe 750-ish megabytes of RAM. But it'll get to 1.7. I've even seen it get up to about 1.9 gig. So yeah, GNOME is big. So if you want to find out on your system what's going on, you can grep slab. Now slab is not a full look at the kernel. It's looking at individual components, but you can look inside of procmeminfo, and you'll get the full story of how much memory your system is taking. You can cut the caches out because the caches are counted. The file caches are counted. You can echo a 3 into procsysvm drop caches, and it'll clear all the caches out of memory. So, but they'll fill back in again as the system is active. But if you hurry up and you run your meminfo again, you should catch it with a minimum footprint of file caches. You can also do it in real time. There's a utility called SlabTop, but you have to be sudo to run it, and it works like top, where it'll refresh occasionally, and you're looking at the total active total for that one to see what your total memory use is. And again, it's using file cache, so you can use the same trick about putting the 3 into the drop cache, and that will give you a view of the system with just the kernel being used. So, and you'll probably find a lot of variation depending upon what systems you're running, and of course what applications you have resident in memory. So I think that's where I'm going to leave things today on this topic about the UNIX philosophy. It was a concept that allowed the developers to create code in such a way that that we had some ability to control how large things got. To give you some idea about the bloat that has happened in Linux, in the Bell Labs version of the man, which is the thing that prints out your manuals to the screen, if I were to do a man on Unix, I would get one page, a very concise one page of options to follow to be able to print out the man. And look at what Linux is now. Just this. Okay, so we have ls, man z, man a, man t, man k, man f. There's a whole bunch of crap here about POSIX. There's defaults. There's more options, minus, and they're not even in. These aren't even mixed in correctly. So these are minus capital C, minus D, minus capital D, minus warnings. Oh my God, it just goes on and on and on. I can tell you that if someone submitted this code to Thompson and Ritchie back then, they would have taken this and just got thanks in the trash. They wouldn't, this was garbage. They would never have done this. I mean, it just goes on and on and on. This is crazy. So, and that's the problem you have. I know that one of the things, in summary, one of the things that I ran into a lot, especially with large programs, and I'll tell you a story about IBM's DB2. So what happens when you have large programs? Some manager will say, okay, I'm going to allocate, you've got 2 days to get this program change that we need into this monolithic monster of a program, and we need to have this change in 2 days. Well, the programmer doesn't, I mean, you think in 2 days they're going to be able to find the location in that code to say it's 1 million lines of code? You think they're going to find that location in the code in case somebody has documented it well? Probably not. Probably the first thing they'll do is they'll just go find the main branching, the main execution loop of the program. They'll go write a function, they'll insert their code, they'll go branch to the function, do whatever changes they got to make and return, and cross their fingers and hope it doesn't blow something else up in the program that they changed the data. And that's what a lot of them do, and that's how this bloat begins. IBM, I was there when DB2 was being rewritten, and I was talking to one of the developers up in Toronto where they did the development for DB2, and they said, I was up there, I was working on a project for a customer, and I remember asking them, and do you guys always just drop out of the sky and just blow away a working environment and start over? He goes, yeah, it's planned into every single product that we make. The software has a fixed lifespan. I don't remember what it was. It could have been 8 years, could have been 10 years, but after that time period expires, IBM just flushes the code. The OS 360 lasted from about 1963-ish until about 1972, and then it was replaced with OS VM. OSVM lasted for a number of years, and it was replaced with VMS or VM. It was some VM, maybe it was VMS, I don't know. But I didn't work for IBM. That didn't really care about their operating systems. I thought their operating systems were garbage anyway. So yeah, that's bias. That's personal bias. But yeah, so so the point is that if you are using monolithic programs, you need to build into some kind of self-destruct mechanism that at a certain point you just blow the thing up and start over. Yeah. I also remember there was another time where I was working with a young developer. She had less than a year of experience, maybe she had 6 months, maybe 4 months in the job. She didn't really understand e-commerce systems, and I was working on one, was working on some changes for customization for a customer that had some specialized needs for shipping and tax calculations. And so we handed her that job to do because she thought she could do it. After about 4 weeks went by, she wasn't finished with it, and we needed the code in order to start testing. And so I went over and looked at, it was over in a different building where they had done this coding. And so I went over and I was looking at it. I couldn't make heads or tails out of it. I didn't know what the hell she was doing. And I don't think she did either. I think she had painted herself in a corner and gotten stuck. It wasn't working. That was the bottom line. So I could have spent 3 days and I probably could have figured it out and fixed it, but I just didn't have time. So I just trashed it. I just threw it away and I started over. I wasn't trying to hurt her feelings or anything like that. It was just like, hey, look, I've got just this afternoon to work on this, and I don't have time to do this. So I worked on it for about 4 hours, got it finished, got it tested, got it incorporated in the program, was all done, and it was working. So I just went back to the other side and left it. So I mean, that happens. I mean, just sometimes you get into a situation where something, you just, what the hell are you doing? And you just destroy it. Anyway, that's where I'm going to leave things today. The UNIX philosophy: small, concise, and compositable programs. So we want things that are reusable, and that's what we're trying to do. So I think with that, I'm going to sign off for today. I hope you enjoyed this video on what the UNIX philosophy was to Bell Labs, because they're the creators of it. Hope to see you all again real soon, and bye for now.